All right. So, hope you had a wonderful Christmas, and hope you got the gifts you guys wanted. It is now Sunday, which is 2 days after Christmas, and now we're going to continue lessons. So, on Friday, some of you came. I saw that, but there was no class Friday or Saturday. So we're going to be continuing what we stopped on Thursday. So we had no classes on Friday, Saturday, obviously, but we're going to continue with what we have today. Yeah, so hope you guys had a great break. New Year's is coming up, so hopefully that'll be fun too. But before we go on to New Year's, we're going to finish the fifth grade curriculum. So starting with chapter 8, which is dividing fractions. So if you remember on Thursday, we started multiplying fractions and stuff like that. So let us continue. So dividing fractions. So if you think about it, if you think hard enough, it would seem very, very weird. So fractions themselves are also division, right? 3/5 is equal to 3 divided by 5, right? So if I divide a fraction, I'm just dividing a division. So that's kind of doesn't make sense, right? So like, for example, 1/2 is equal to 1 divided by 2. So how do we divide something that's division? So it seems pretty weird at first, but let us check out some examples. For instance, let's say I need to walk 5 miles every day, right? Every 1/2 mile, I stop because I'm out of shape. So how often do I stop? So I have to walk 5 miles, right? But every 1/2 mile, I have to stop because I'm really tired. So how much times do I stop? So the question becomes 5 divided by 1/2. So where could we start? Instead of doing it directly, let's try something else. Let us try 1/2 times blank equals 5. So the number that would equal 5 is 10, because 10 divided by 2 is 5. So the number that when you multiply times 1/2 equals 5 is going to be 10. Okay, that just means 5 divided by 1/2 equals 10. So we can do it that way. We can think of a number, let's say 3/5, 1 divided by 3/5. So what number would that be? We just find a number that when you multiply it, we'll get back to 1. For example, in this question, we did exactly that. We just reverse engineered our way into doing it. But so how do we officially do it? So division and fractions are basically the same thing. So 1 divided by 2 is equal to 1/2. 3 divided by 4, 3/4. So what does that mean? If I have 6 friends and 4 pizzas, how much does each friend get? They get 4/6 of a pizza. And that's obvious, right? We already talked about that. But if you are very big brain and you notice that 5 divided by 1/2 was 10, was a little fishy, there's something going on here, you're not too well off. Let me give you some more examples. 3 divided by 1/4 is 12. 1 divided by 1/3 is 3. So basically, what are you noticing? It's just the top times the bottom. Is that a coincidence or is that a rule? Well, let me give you a hint. It is a rule. So before we go on to that, we have to learn what a reciprocal is. So what is a reciprocal? It sounds like a very complicated word, but it's literally the only thing you have to remember is a reciprocal is a fraction that's flipped over. For example, the reciprocal of 1/3 is 3. Also 3/1. The reciprocal of 256 over 1024 is 1024 over 256. So all you're doing when you do reciprocal is flip the fraction over its head. So basically, you see me flipping this table. That's basically what we're doing. We're taking the fraction, the top and bottom, and we're swapping them. We're flipping them over. So if we see this, 5 divided by 1/3, right? 5 divided by 1 divided by 3. 5 divided by 1/3. Or 1 divided by 1/4. What we do is we reciprocate the bottom, the fraction that's on the bottom, and then we get rid of we reciprocate it, and then we get rid of the division. So for instance, we flip 1/3, so it becomes 3, and then we multiply. So it becomes 5 times 3. How about for 1 divided by 1/4? We flip 1/4, and then we do 1 times 4. So the answer for the top one is 15. The answer to the second one is 4. So again, what we do when we divide fractions is we take the bottom, the one we're dividing by, we flip it, and then we multiply it by the top. So we flip it, then we multiply it by the top, basically. So your brain is probably like, that's very, 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 that's hurting my brain a bit. So all we did was flip the fraction over and flip the sign. So how about you guys try these questions? Yeah, today, by the way, is another short one. But it's the division by fraction requires a lot of practice. So I'll give you guys like 4 or 5 minutes, and then we'll go over them. These aren't too hard. Just remember the general rule, which is flipping the bottom or flipping the second number, and then multiply. Okay, so that has been indeed 5-6 minutes. So let's go over them. So first one, obviously, was 24. Nothing too difficult there. Second one is 72 because you first of all you flip the bottom. 1/24 becomes just 24, and you multiply by 3. So 24 times 3 is 72. Okay, number 3. Some of you got tricked by it. You flip the fraction over, right? It becomes 5 divided by 6. So 5 times 5/6 becomes 25/6. You flip the 5/6 and then you multiply. So 5 times 5/6, 25/6. Okay, so how about 4? Flip it over, it becomes 5. 1/5 times 5, 1/5 times 25 is 5. And then 1/3 divided by 6, well, you flip 6 over, so it becomes 1/6. 1/3 times 1/6 is 1/18. So yeah, a couple of these are pretty tricky because I kind of made it seem like I was gonna leave it somewhere else, but it wasn't. So chapter 9. So we're gonna delve into the world of algebra today. Today's chapter is really short. Like last time we multiplication was really short because it's just multiplication. So today's gonna be pretty short. So before we move on, let us talk about line plots. So let's learn a little bit about line plots. So what is a line plot? So before we go into that, let's read this problem. So I have a jacket that only uses buttons larger than 1/4 inches. So I have buttons of all sizes. I have buttons of 1/4, 3/4, and 1/2 inch. So let us see how much buttons I have. So I measured out my buttons, right? And I have a total of 6 buttons: 1/4, 3/4, 1/4, 1, 1/4, and 1. So how can I order my buttons to see which ones are longer than 1/4? So let us use a line plot. So this is going to be our line plot. I drew a line and 3 plots for the 3 measurements we have. So one of them is 1/4, the other is 3/4, and then 1. So this is a line with 3 plots of my measurements. So I plot down how many of each I have. So let's count the 1/4. So I have 1, then I have 2, and 3. I have 3 1/4 buttons, inches buttons. So I put 1/4, 3 X's or 3 check marks or 3, whatever symbol you want here. I just put X's because they look cool. All right, so how about 3/4? There's only one 3/4 inch button. And then how about 1? There are 2 3/4 inch buttons, 2 1-inch buttons. So basically, line plots, you write down how many of a something that you have. So hopefully you understood what that was. It's basically just putting it on a graph and seeing. It's really easy to organize. So instead of having to look at this and look and say, oh, I have 1, 2, 3, I have 3 1/4 buttons. You can just look at this graph and say, oh, I have 3 1/4 buttons. Really easy. And or if you want to know how much 1-inch buttons you have, you say, oh, I have 2 because there's 2 X marks. Okay, so ordered pairs. So we'll go over what an ordered pair is right now. So hopefully you guys know what a coordinate grid is. So on a graph, we have the horizontal line, x-axis, and the vertical line, y-axis. So this is an example of a graph. So we have a x-axis, which I'm going to show right here, which is this long, thick line right here, and then the y-axis, which is going up and down. It's basically, so x-axis goes left and right. The y-axis goes up and down. So every single point on the graph is called an ordered pair. First the x, then the y. For instance, 1, 2. So we look at the x-axis. This is the point 0, 0 right here. So if x is 1, we go on the x-axis to 1 right here. And then y is 2. So we go up twice. So 1, 2. So the point 1, 2 will be right here because the x is 1, the y is 2. So how do you read graphs? So the first number in x, y is the x coordinate. We look at the horizontal line, the one that goes from left to right, and we look at the number on the line. For instance, like I said before, if we have the point 1, 0, the x will be 1. If we look at, so right now we're looking at the point 1, y. So how about the y? So the next number is the y coordinate. So we already talked about the x coordinate, which in this case is 1. We check the vertical line, the one that goes up and down. So we look at this point, and it's right at the 2 line. So the y is going to be 2. So now that means the ordered pair is 1, 2. Because the x is 1, the y is 2, and it becomes 1, 2. And that's pretty much how it's done. So here's something top secret. What is the ordered pair of 0, 0? So it's going to be right here when x is 0, y is also 0. And there's a secret word for it. Well, it's not secret, but it's just a word that all of us use. It's called the origin. So hopefully you guys should probably just know this, because this is pretty important later on. Once you become up there, you have to know what an origin is. And you have to know what mantissa and abscissa is, all those complicated words. But this is the origin, which is just 0, 0. Okay, so how about you do some practice? So basically these questions are asking, where are the places? So basically, I need you to find the x and the y, and then go ahead. If you have any questions, you can go ahead and ask, but I'll give you guys like 5 minutes to try to solve these. Oh yeah, a hint. The first question is pretty easy. Second question is just asking for the length. So length on a number line, you just count how much is it weigh. So for instance, let's try the school and then this point. So we count 1, 2, 3, 4, 5, 6. So from the school to this point, it's going to be 6 units, because it's going to be 6 squares away. So basically just count how many squares are in between, or lines or line segments, and then you'll find the distance. All right, so hopefully that was enough time. We're going to go over them right now in case anyone has questions. So, first question: which building is located at 5, 6? This one was pretty easy. You just look at the first one. X is 5, so you look at 1, 2, 3, 4, 5, and then we go up 6 because it's at the sixth part. So 1, 2, 3, 4, 5, 6, and the only possible answer was Price Slicer Market, which hopefully you guys got. And then the second question, which is the distance between Kip's Pizza, which is right here, and the bank, which is right here. So you just count how much units are in between. So 1, 2, 3, 4, 5, 6. There are 6 units between Kip's Pizza and the bank. So 6. You can say 6 or 6 units. It doesn't really matter. If this was labeled in inches, you would say 6 inches. Where it was if each square was labeled in feet, you say 6 feet. But they didn't give you any units, so you just say 6 units, or you can just say 6. Okay, so how do you make a graph? So do you guys want to make a graph? I'm sure you do. So graphs are super exciting. So although you might think it's not, it's really important to know how to draw graphs. Even I need to know how to draw graphs. For instance, some problems are really only possible if you draw the graphs or make easier. So how do you use data from a table to put into a graph? Okay, so let's say each year I grow some amount of feet and I record my height every single year. So this is my height in feet. So the first year I grow 2 feet. Second year I grow 4. Third year I grow 6. Fourth year I grow 8. If X is the years and Y is how tall I am during that year, how can I graph it? So I can put it into a graph, right? I can just plot 1, 2, 2, 4, 3, 6, 4, 8. So it's pretty simple stuff. Like one function is going to be the one input is going to be the X, the output is going to be the Y, basically. Okay, so I know you guys probably don't have graphing, so you really don't have to do this. But if you can, then I guess you should. But I don't know if any of you guys have graphs. So if you could do this, we could go over it, but we're not going to do it now. So this is basically the answer. So 1, 4 is our first order pair. 3, 12, 5, 20, 7, 28. And then the same thing for number 2. So basically just put it into order pairs. Nothing too complicated here. Okay, so a couple more things before we end today. Line graphs. So what is a line graph? So let's say I travel for 3 hours. The first hour, I go 2 miles. Then I stop for the second hour. Then I travel 1 mile for the last hour. So I could do it like this. So I start at the origin, 0, 0, right? The first hour, which is going to be 1, I go 2 miles, which is 2. So I go for the first hour, I go 2 minutes. 2 miles. Then the second hour, I do nothing. I stay there. So my graph is flat. I didn't move from my spot. I just stayed in the same spot. Time goes on, but I didn't move. And then for the last hour, I travel one time. So I go from 2 to 3, and then the time is always moving. It goes from 2 to 3 as well. So basically, you can just take the information from a problem and put it into a line graph. Nothing too complicated there. So I have to connect them. So 0, 0 to 1, 2, right? And then 1, 2 to 2, 2, 2, 2 to 3, 3. You just connect them based on the information that you're given. So patterns. So every single week, one more thing before we end class for today. Every single week, I go into the Apple store and I get 2 movies and 6 weeks. 6 movies. 6 movies during the quarantine. So if I do 6, think of CDs or something. It's not weeks. Every single week I go to the Apple store to get 2 movies and 6 CDs during the quarantine. If I do this constantly, how many do they compare? So let's say 2 movies and 6 songs. So the first week I get 2 movies and 6 songs. So 2 and 6. Second week I have a total of 4 movies and 12 songs, right? Because I add 2 and 6. Third week 6 and 18. Fourth week 8 and 24. I could keep going, but you guys can see a pattern, hopefully. So we can see that 6 divided by 2 is 3. 12 divided by 4 is 3. 18 divided by 6 is 3, and 24 divided by 8 is 3. So basically, every single time I increase by 2, I'm increasing by 6. So it's still saying the ratio is still saying the same as 3, but only the amount has increased. I mean, this isn't too important to know, but it's pretty interesting nonetheless. Anyways, so no matter what week it is, I will always have 3 times more songs than movies, or 1/3 movies than songs. So if I have, let's say, 100 movies, then I know I'll have 300 songs because it's always 3 times more. So we just basically just take information that's from here and we learn. But as of today, that is basically it. These last few lessons are really short because they're not too complicated. But we're going to be going over basically review soon, and then we're going to finish. But that's literally it for today. I know today was really short, but that's just how it is for these lessons. So hopefully you had a great break. I'll see you tomorrow. If you don't have any questions, bye.